Hello Geometry. So today we're going to be learning about adding and subtracting radicals. So our first problem here is pretty simple. We've always dealt with some variables. 2x plus 4x. We should all know that that equals 6x. Radicals are just going to be like our variables. We're going to leave them in our problems. So next one, we take a look and we have 2x squared plus 3x. As we know from our variables, we can do nothing with this problem, and it's going to stay as 2x squared plus 3x. So just like our variables, when we add and subtract radicals, they have to be the same radical for us to add and subtract them. So one more example here. 3y minus 2x. We see that they're not the same, therefore we can't do anything. So leave it as 3y minus 2x. Simple enough. So now let's get into our radicals. So we have 3 rad 2 plus 2 rad 2. So now take a look. Imagine our rad 2's as if they were x's. If we have 3x plus 2x, it would be a 5x. So same thing here, a 3 rad 2 plus 2 rad 2, we get 5 rad 2. These are going to get a little harder, so let's pay attention and make sure we understand what's going on. So next, 4 rad 3 minus a rad 3. So we have to remember that there's a 1 here. If we have 4 radical 3's minus 1 radical 3, we are left with 3 radical 3's. Number 6. Make sure we're copying these down. So we have 4 radical 6 minus a radical 3 plus 2 radical 6. Like I said, variables, we got to make sure we're only going to combine like terms. So we have 2 radical 6's and 1 radical 3. Therefore, we're going to simply add the radical 6's. So we have a 6 radical 6 minus a radical 3. And we're going to leave it just like that. Next, now it's getting a little longer. Same thing. Let's combine our like terms. So let's highlight them. We have radical 7 there, a radical 10 here, radical 10 again, and lastly a radical 7. So we're going to combine the radical 7's and combine the radical 10's. So a 2 radical 7 minus an 8 radical 7 gives us a minus 6 radical 7. Then a minus 3 radical 10 plus 2 radical 10 is a minus radical 10. Next. 3 radical 8 plus 2 radical 2 plus 4 radical 2. Same thing, we're going to add our like radicals. So we have 3 radical 8 plus a 2 and a 4, which is a 6 radical 2. Now here, we always have to simplify. So let's take a look at that radical 8. We know that radical 8 breaks into a radical 4 and a radical 2. Now this radical 4 is just 2. And now we see 3 times 2 is 6 radical 2 plus a 6 radical 2. Now we have like terms, so we can now add those radicals. So we get 12 radical 2. Remember, when we're adding radicals, we're not changing the radical. Number 9. 4 radical 12 plus 2 radical 27. Here we have no like terms, but we can simplify. So let's take a look. We have 4. We could break that 12 into a radical 4 and a radical 3 plus a 2 radical 9 radical 3. When we simplify here, we get 4 times 2 times a radical 3 plus 2 times 3 times a radical 3. So an 8 radical 3 plus 6 radical 3. So an 8 plus 6, we get 14 radical 3. Alright, moving on. Here, so once again, these are going to keep getting a little harder. So we have a 5 radical 75 plus a 2 radical 50 minus a 4 radical 3. Once again, simplify. 5 radical 25 radical 3 plus 2 radical 25 radical 2 minus a 4 radical 3. Therefore, 5 times 5 radical 3 plus 2 times 5 radical 2 minus 4 radical 3. Let's clean this up. We get 25 radical 3 plus 10 radical 2 minus 4 radical 3. Lastly, going into adding or subtracting, here we have like terms of radical 3's. So we have a 21 radical 3 plus 10 radical 2. Next, 2 radical 9 plus 4 radical 18 plus 3 radical 8 minus 2 radical 32. Simplify everything here. So we have, right away we see that radical 9 is simply just 3. And we're going to break everything down. 4 radical 9 radical 2 plus 3 radical 4 radical 2 minus 2 radical 16 radical 2. Multiply 6 plus 4 times 3 radical 2 plus 3 times 2 radical 2 minus 2 times 4 radical 2. Let's clean everything up. 6 plus 12 radical 2 plus 6 radical 2 minus 8 radical 2. Like we've been doing. Radical 2, radical 2, radical 2. Let's add those all together and we get 6 plus 10 radical 2. Now moving on. So now we're going to start adding some triangles in here. So for the following triangle, we want to find the perimeter. So we should know by now perimeter is just adding up all the sides. So this one's nice and simple. We have 3 plus 5 plus radical 34. So now 3 plus 5 is an 8 plus a radical 34, and we're done. There's nothing we could do with that radical 34. Next, here, these are all right triangles, by the way. We're missing our hypotenuse, so this is when we have to go back to the Pythagorean Theorem. So we're going to use a squared plus b squared equals c squared, where we have a is 5 plus b, which is 8, and here we are looking for our c. 5 squared is 25. This is where you should all know your perfect squares. 64 equals c squared. Therefore, 25 plus 64, we have 89 equals c squared. Therefore, we have to square root both sides. We have the square root of 89 equals c. Like we did before now, finding perimeter, we need to add all our sides. 5 plus 8 plus the square root of 89. And we get 13 plus the square root of 89. Next, 2 more problems. So number 3, same thing we're going to do. We need Pythagorean Theorem. A squared plus b squared equals c squared. We got to plug in 7 squared plus 2 radical 3 all squared equals c squared. 7 squared we know is 49. But what about that 2 radical 3, all of that squared? So let's take a look. So it's just like multiplying. So what if we had 2 radical 3 times 2 radical 3? Isn't that the same thing? So we're going to multiply our coefficients, and then we're going to multiply our radicals. So we have 49 plus 2 times 2, which is 4. Radical 3 times radical 3, which is just a regular 3. So therefore, when you multiply radicals, so when you square radicals, you square the first number. So you square it here, and you square it there. So here we have 49 plus 12 equals c squared. Lastly, we find 49 plus 12, which equals 62. So we have 62 equals c squared. Square root both sides, and we get c equals radical 62. Let's plug that in. And now we have enough to find perimeter. Just like we've been doing, 7 plus 2 radical 3 plus radical 62. 7 plus 2 radical 3, can't do anything. 2 radical 3 plus a radical 62, not the same. And can we break down that radical 62? We can actually not. So we're moving on. We're all done here. Last problem. Number 4. Here we have an isosceles triangle. 2 legs, 4 radical 3, 4 radical 3. Same as always. A squared plus b squared equals c squared. 4 radical 3 all squared plus 4 radical 3 all squared equals c squared. Like I said before, when we square, we're just going to square each portion. So we have 4 squared, which is 16, plus a radical 3 squared, which is just 3. Same thing, 16 times 3. And that all equals c squared. Now, 16 times 3, 48, plus 48 equals c squared. Therefore, we get 96 equals c squared. Take the square root of both sides, and we get square root of 96 equals c. Let's plug that in. And now we want to find perimeter. So we have 4 radical 3 plus 4 radical 3 plus radical 96. 4 radical 3, 4 radical 3. We get 8 radical 3 plus 96, square root of 96. And we can't do anything there, so we leave it. Therefore, what we want you to know, adding radicals, they have to be the same radical. Subtracting radicals, same thing, they have to be the same. Alright, make sure you have this all complete and written out to hand in on Monday.